Hi everyone, it's Adam again. This is, I think, the 7th video in the series of going through Maths Paper 1. In this video, I'm going to go through how to solve quadratics using the minus b formula, and then how to solve cubics. So I'll do maybe one question of factorization, but this is mainly going to be the minus b formula. So, first of all, I want to show everybody where the minus b formula comes from. So, to the best of my knowledge, there's no derivation out there for the minus b formula in books. So, I'm just going to show you where it comes from. So, quickly, you start off with ax squared plus bx plus c equals 0. Okay, and I want to isolate x, basically. This will be covered later. It's called completing the square. But this is equal. Okay. I'll just do it in pink, just to prove that these two lines are indeed equal. If I do so you get this, and then if I multiply these two things together, I'm going to get ax squared. Oh, sorry, I made a mistake. That should be plus, and the other one should still be minus, but that should be plus. Sorry, that's my fault. Just while I'm checking it. Okay, so we get this. So this is going to be plus bx. So what happens is I'm going to get this multiplied by this multiplied by a gives me bx over 2, and then this multiplied by this multiplied by this gives me a bx over 2 as well, and then when I add them together I get a bx. That's where that comes from. Then you get your last term, which is going to be plus b squared over 4a. So that's the b over 2a multiplied by b over 2a is b squared over 4a squared, multiplied by a is b squared over 4a, plus c minus b squared over 4a equals 0. This cancels, sorry, I should do a different color. This cancels with this, and so I'm just left with ax squared plus bx plus c equals 0. Okay, so this is just to show that this line is indeed correct. So now I'm going to get that this then transforms to x plus b over 2a squared equals, it's going to be b squared over 4a squared minus c over a. So I brought the plus c minus b squared all over 4a over to the right hand side, so it becomes plus, and then I divided both sides by a. Square rooting both sides, I get that x plus b over 2a equals plus or minus the square root of b squared over 4a squared minus c over a. And this is equal to plus or minus the square root of of b squared minus 4ac all divided by 4a squared. Also, I should probably highlight why there's a plus and minus here. The reason is that if you have something like, I'll just draw it on the right, sorry, on the left, I might just do it here. So if you have that x squared equals 4, this means that x could equal plus or minus 2. So the thing is, because you're squaring it, you don't know if x is positive or negative, and therefore you can't discount the basically you know the magnitude or the size of it, but you don't know whether it's positive or negative. So that's why here there's a plus and minus. So I get this. This is equal to plus or minus the square root of b squared minus 4ac all divided by 2a. So the square root of 4a squared is 2a, and that's just down the bottom. And then you get that means that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And so this is the minus b formula. So this is how you solve quadratics. Okay? That derivation or proof, whatever you would like to call it, that's not going to, that isn't going to come up, okay? The examination commission is never going to ask you that, so don't worry if you don't understand it. That's just to give you, because you're just given this formula and you're expected to use it, and no one ever tells you where it comes from. So this is that, okay? Just to give you a bit of meaning behind the formula. Okay. So now, what we can do is, we can just solve a couple of quadratics. So it could be something like 2x squared minus 13x plus 18 equals 0. So if I use the minus b formula, I get that x equals, so minus b. So actually, hold on, let's take it in a couple steps. So first of all, what is a, what is b, and what is c? So a is 2, b is minus 13, and then c is 18. So now always be careful when you're doing the different a, b, and c, that if there's a minus, it needs to go with it, okay? This gives x equals, so it's minus b, so it's minus 13, or I'll leave it for a second. So it's minus 13 plus or minus the square root b squared, so it's minus 13 squared minus 4 multiplied by a multiplied by c, which is 18, all divided by 2 times a, which is 2. Okay, so we get x equals 13. So minus by minus is plus, plus or minus the square root of 13 minus 13 squared, that's 169, minus 4 times 2 is 8, multiplied by 18 is going to give me, I think, 144, all divided by 4. Alright, so here we get x equals 13 plus or minus the square root 169 divided by minus 144, sorry, is 25. 4, so you get x equals 13 plus or minus 5 over 4. So we get that x equals, so if I add it first, I get 13 plus 5, that's 18. 18 divided by 4 is 4.5. And then the minus, if I do 13 minus 5, I get 8. 8 divided by 4 is 2. So what you do is, what this notation means, it means you say that your first answer is 13 plus 5 divided by 4, and then your second answer is 13 minus 5 divided by 4. So you plus first and then you minus second, and that gives you your two values here. Okay, So hopefully that is not too bad and not too difficult. Now you can get into more difficult problems, okay? I'll do one more of these, because sometimes they mightn't come out nice like the way they just did. So here we have 3x squared plus 12x plus 1 equals 0. So again, what are A, B, and C? So A is 3, B is 12, and C is 1. So, so this now, if we plug this into the minus b formula again, we get x equals minus b, so it's minus 12 plus or minus the square root of b squared, so 12 squared, minus 4 multiplied by a multiplied by c, all divided by 2a. So this is going to be minus 12 plus or minus the square root. 12 squared is 144 minus 12 all divided by 6. Okay? So it's minus 12 plus or minus the square root of 132 all divided by 6. Now, you can't calculate this in your head because the square root of 132 isn't a nice number, it's a square root. It's going to be 11 point something, probably around 11.45 or whatever, 11.5 give or take, something like that. So what you do is you say, okay, that means x is equal to minus 12 plus the square root of 132 over 6, or x can equal minus 12 minus the square root of 132 all over 6. And then you just plug these into your calculator. So you plug them into your calculator and you get a certain number. I will just grab my calculator. So now I'm just going to type that into the calculator and see what I get. So this is going to give me minus 0.085, and then this one is going to give me minus 3.915. So those are your two answers in this case. And also this is third so because sometimes they can ask you to leave it in third form, and what they mean is they just say, okay, just leave it in the square roots. There's no need to evaluate it and get your decimal places as I have here. So if they ask you for give your answer in a third form, you can just leave it in square roots and it's fine. Okay, now I'll do one question about weird looking quadratics. So it could be something like this. So say 4 over 4x minus 3 plus 1 is going to equal 2 over x minus 1. So again, remember you're solving for x and there's an equal to sign. So I don't have to be careful about how I'm adding fractions. I can just multiply whenever I choose. So here what I'm going to do is I'm going to multiply everything by x minus 1 to get rid of this fraction. And then I'm also going to multiply by 4x minus 3 to get rid of this fraction. Okay? So first things first, let's multiply by x minus 1. So if I multiply by x minus 1, I'm going to get 4 multiplied by x minus 1, which is 4x minus 4 all over 4x minus 3 plus 1 multiplied by x minus 1 is just x minus 1 equals 2. And now I'm going to multiply by 4x minus 3. So if I multiply the left term by 4x minus 3, I'm just left with 4x minus 4. Plus x multiplied by that is going to be plus 4x squared minus 3x. Minus 1 multiplied by 4x minus 3 is just minus 4x plus 3 equals 2 multiplied by 4x minus 3 is just going to be 8x minus 6. Okay? So now, the only x squared term I have is this. This term has 1x. This term has 1x. This term has 1x. And this term also has an x. Okay? This term is a constant. This term is a constant. And this term is a constant. Okay, so I'm going to add those together. So this is going to be equal to 4x squared. All right. Now the linear term is going to be 4. So the 4x minus 4x is just that. If I bring the 8x over, it becomes a minus 8x. So minus 8x minus 3x is minus 11x. I get minus 4 plus 3, it's minus 1. If I bring the minus 6 from the right hand side to the left hand side, it becomes a plus 6. So it's 6 minus 1, so it's plus 5. Equals 0. Okay? And again, you can use the minus b formula here, and you can also factorize. I'm going to use the minus b formula just because I've been using it so far. So here, actually, sorry, I haven't actually gone through how to factorize and solve it. Okay, yeah. Let's do that. So you can also use factorization to solve these. So in this case, so as before, I'm going to get the factors of 4 are 1 and 4, and 2 and 2. And then the factors of 5 are just 1 and 5. So now, I'm going to try 2x and 2x. This is positive, which means the sign here and here must be the same, and it must be the same as this. So so both of these are negative. Okay? Oh, sorry. Okay. I actually can't factorize this, I don't think. Sorry, I assumed I could. Okay, no, I made a mistake. I may cut that out, I don't know. But, okay, at least isn't even, you know, the people who've been doing this maths for years and years still make mistakes. So, yeah, I need to use minus b formula on this because I don't think it factorizes, or at least I can't see it to factorize. And that's another very good tip, that when you're doing these, do look for about 5 or 10 seconds to see if you can factorize it. If you can, fantastic, but if you can't, like, just use minus b formula because it'll always work. So A equals 4, B equals minus 11, and C equals 5. Okay? So if you use the minus b formula, I get x equals minus b, so minus 11, plus or minus the square root of b squared, which is minus 11 squared, minus 4 multiplied by a, which is 4, multiplied by c, which is 5. All divided by 2 multiplied by a, which is 4. So I get x equals, minus by minus is plus, so it's 11. So plus 11, plus or minus the square root of 121 minus 80 all over 8. So x equals 11 plus or minus the square root of 41 over 8. And those are then your two answers to that. So yeah, just as well I didn't try and factorize it for any longer, because you definitely could not factorize that. Okay. So yeah, that's that. That's how you solve quadratics. And then there's another one, which is how do you solve something like this? And then this. So again, I said it in the last video, if there's two things you don't know, so if there's n things you don't know, you need n formulas or n relationships between different numbers, or you need n bits of information. So here we have x and y, and therefore we have two formulas. Now, before, the formulas were always linear, and when I say linear, I mean that there was no x squares or x cubes or x times y squared. There was none of that, whereas now there is. So how do you solve something like this? This is one thing that you probably couldn't solve on your own unless you were showed it. So this is something to definitely have a look at before you do your leaving cert, your pre, your exam, whatever it is, whatever it may be. Because this stuff is quite it's quite challenging, but once you know what to do, it's very easy. So you start with the linear term and you solve for either x or y. In this case, I'm going to solve for y because it only appears once in the nonlinear equation. Okay, so this is called linear. This is none. So I'm going to solve the linear equation for y. So y equals what? So y equals 1 minus x over 4. So what I did was, in the top equation, I brought the x over to the right, so it became a minus, and I divided by 4. Now I'm going to plug this in here. So I get 2x squared plus 3x multiplied by y. Y is now 1 minus x over 4. And this has to equal 35. Okay? So, now again, this 4 is quite a 9. So I'm going to get rid of it. I'm going to multiply by 4. Okay? Sorry, let me just... Yeah. I'll just get rid of a couple of these because they're kind of useless colours. Okay. So now if I multiply everything by 4, I'm going to get 8x squared plus 3x multiplied by 1 is just 3x. 3x multiplied by minus x is minus 3x squared equals 35 multiplied by 4 is going to be 140. Okay? So now, this becomes 5x squared, so I'm doing 8x squared minus 3x squared plus 3x minus 140 equals 0. Okay? Okay, now, does this factorize? I don't know. Okay, I think it does. Yes, it does. Okay, now, the only reason I'm factorizing this is just to show you how it can be done. You should use the minus b formula here. You look at it for 5 seconds, and if you can't spot it, what the answer is, then you know what the factors are, then just use the minus b formula. But I do want to have at least one example, worked example of me actually doing it, of getting factors, because I don't know when the next one may or may not be. So I end up with this. This factorizes into 5x and x, and this is going to be plus 28, and this is going to be minus 5. Okay, so again, this becomes 5x plus 28 into x minus 5 equals 0. So now that you have that this thing equals 0, there's only two options. Either this, for these two things to be 0, you have something multiplied by something else. So you've one bracket multiplied by another bracket. So the only way that the product can be 0 is if one of them is 0. So either we have the bracket on the left has to be 0, or we have the bracket on the right. If we assume the bracket on the left is 0, we say that 5x plus 28 equals 0. So 5x equals minus 28. So x equals minus 28 over 5. Now if we assume that x minus 5 is 0, then we just get that x equals 5 is the solution. And remember, we got that y 1 minus x over 4. So if x is equal to minus 28 over 5, we get that y is equal to 1 minus 28 over 5, so plus 28 over 5, all divided by 4. Multiply the top and the bottom by 5, so we get 5 plus 28 over 20. So y is going to equal 33 over 20. So again, this can be written as minus 28 over 5, 33 over 20. So that's that's solution. Now the other one, if we say that y equals 1 minus 5 over 4, so y equals minus 4 over 4, so y equals 1. And this means we have it's 5 and 1. So those are your two solutions. Okay? Sorry, minus. Sorry, so yeah, it's minus 1. So yeah, that is how you solve them. So you always start off with the linear one. You solve for x or y, whichever one you prefer. Here I solve for y, and then you take that and you plug it into your second equation. And then you get a quadratic and you solve it, and you plug it back into your linear expression, which is this one. Okay. Okay, so that is that, and that's how you solve those ones. Yeah, now there's kind of an awful lot of stuff about graphs. I suppose I may as well get into it. Okay. So this is kind of going into factors. And what a factor means. So we say that if x minus a is a factor of f of x, then f of a equals 0. Okay? Where f of x is a mathematical operation involving x and depending on x. So that probably looks awful. But some examples would be f of x equals x squared, f of x equals x plus 2, f of x can be equal to x minus 17 plus x to the power of 3.2, etc. Very hand wavy. You can think of f of x as just being equal to y. Okay? Alright. And also up here we have that a root of f of x. So we have root, we have factor, and we have defined f of x. Okay. This is kind of getting into the functions. The functions will be in a couple chapters, and we can go through them then in a bit more detail, but you have this thing called the factor theorem, which is just the definition that I have up there in blue, that's what it means to be a factor. And yeah, that's it. So you have another thing. There's a few definitions, which I suppose I may as well go through. So, yeah, so root is very important. So if it's a root, that means that if you evaluate f at the root, you get 0. So, example, a root of x squared is x equals 0. Why? Because if I sub 0 into x squared, I get 0. And therefore 0 is a root. Okay? Alright, is there anything else I really care about here? I don't think so. Okay. Now, another thing of drawing functions is that you have a polynomial. And this is just equal to a0 plus a1x plus a2x squared plus a3x cubed on. So a polynomial is just something that has a load of x's, powers of x's, okay? Okay, if the highest power in, I suppose, present in the function is odd. So if it's odd, then it could be, so if it's odd, then if the number which is called the coefficient, Eficient, coefficient is positive, then the right arm points up. And then if it is negative, the right arm points down. Okay, so actually this, okay, 1 second. This is actually true if it's even or odd. So this actually works for all of them. So for example, say f of x equals x squared, and I wanted to draw this. Well, this is equal to 1x squared. So my leading coefficient is 1, which is greater than 0. And therefore, when I draw it, the right arm points up. And this is the really, really important part, that your right arm points up when you're drawing it. Okay? Another thing is that quadratics always have a singular maximum or minimum. So they only have one turning point. Okay? Now, you might be looking at that and saying, okay, well, yeah, whatever, the right hand points up or down. Okay, how does that help me? Well, now if we have cubics, say f of x equals x cubed, maybe I'll do minus, just to show. And cubics have 2 turning points. Fx equals minus x cubed plus 7x squared plus 100 or 1000x minus 3. Okay? So again, you look at the leading coefficient, which in this case, sorry, I'll draw the 1 there, just to be completely explicit. Because that is negative, I now know that the function, the right arm points down. So it's going to look something like this. Okay? And that's the right arm, or this is x and this is y. Sorry, I never specified that. So here we have that it goes down. Okay? And it has 2 turning points, which means it'll look something like this, where here it has 2 turning points. So if you have a polynomial of highest degree, then you will have n minus 1, typically. Okay? And then that's how you draw them. Okay? The only ones to look out for where this wouldn't happen would be something like f of x equals x cubed. This looks like this. So this is where it wouldn't happen, when you have something like that. But again, the rule that the fact that the right arm points up, if the coefficient or the number of things you have is positive, in this case it's +1, then the right arm still points up. Okay, and then this one points down. So that's how you would draw these types of graphs. Okay? So yeah, that's just drawing. How you draw graphs. Okay? So that's the thing to remember. If I didn't write it, I will say it. You have your roots, that's fine. If you your highest power, if your number of highest powers is positive, the right hand points up. If it's negative, it points down. This can be thought of as, if you look at this equation here quickly, the reason we only care about the highest power is specifically because if x gets really, really, really big, like I'm talking like 1 billion or 1 trillion, 1 billion cubed is so much bigger than 7 times 1 billion squared. So the idea is that as x gets really, really big, so if x really, really big, we can say that f of x is just going to be minus x cubed, roughly. That's not exactly true, but if x is so gigantic, then the -3 isn't going to matter, the 1000x isn't going to matter, the 7x squared isn't going to matter, so the only thing you care about is the minus x cubed. And that's how we know that minus x cubed definitely does go down. Obviously it goes to negative infinity, and therefore this arm must point down. Okay. So now we have manipulating formulas. So having something like, you have maybe v equals 1/3 pi r squared h. Okay. And what you want to know is, you want to know r equals what? So let's say in this scenario, v is volume, r is radius, and h is height. I have the height, I have the volume, but I don't know what the radius is. How do I solve this equation using the information that I have to figure out what r is? So this is the question. I want to know what r is. So to manipulate the formula, you basically solve for r. So what you do is you just undo everything that's around r. So this is what I'm starting with. This is what I would like to finish with. So first of all, let's get rid of the third. Let's multiply both sides by 3. So we get 3v equals pi r squared h. Secondly, let's get rid of the pi and the h. So I get r squared equals 3v over pi h. So I divided both sides by pi and h. Now I can take the square root on both sides because I have r squared. I only want r. So if I take the square root, I get r equals the square root of 3v over pi h. Sorry. And that's the answer. Now, quick question. Just think about this. Why didn't I put a plus and minus in front of that? because I would have, if I was solving for x, I would have, but I'm solving for r. So why didn't I put a plus and minus there? So just have a quick think. It's because r is positive. It's radius. It's a length, and therefore, of course, if you told me the radius was minus 3 centimeters, that's clearly wrong, and therefore I'm not going to take the minus answer because that's definitely incorrect. Okay, this video is getting quite long. I might just do one more of these and then I will leave it at that. Yeah, there's still a little bit in the chapter. Yeah, I'll just finish this chapter just to get it done. Okay, so that's one. I'll do one more. So let's say I have the square root of x over y equals z, and I want to solve for y. First of all, let's get rid of the square root. Let's square both sides. So I'm going to get x over y equals z squared. Multiply both sides by y. I'm going to get x equals y z squared. And now I'm going to divide both sides by z squared. So I'm going to get y equals x over z squared. And that's how you would do that. Okay. Now we have, yes, just identities. So identities is basically, it's not too bad. So we have, okay, this one looks quite difficult. Yeah, I'll do this one because it's quite hard, and then I can leave it at that. So what you have is you have if x squared minus px plus 1 is a factor of ax cubed plus bx plus c, then prove. So I need to prove that c equals ap, c squared equals c squared equals a into a minus b, and then b minus a equals minus ap squared. So I need to show this. All right. So if this is a factor of this, what does that mean? That means that and this is the first time you're seeing this, that means that ax cubed plus bx plus c is equal to x squared minus px plus 1 multiplied by something else. So basically, if it's a factor, it means that we can write it like this. Okay? Now, another thing, like adding numbers, this has degree 3. This has degree 2. So what do I mean by degree 2? I mean this. The highest power. Okay? And when you multiply a function of degree n with another function of degree m, you add them together. So in this case, this function has to be of degree 1 because 1 plus 2 is 3. Okay, so this thing here is going to be, I'm going to use alpha and beta. You mightn't have seen these symbols before, but I'm going to use alpha x plus beta because I don't know what they should be. Okay, so all I know is that it's degree 1, which means it's a linear thing, so it could be, y equals mx plus c. I don't know what m is, I don't know what slope is, I don't know what the constant is, so I'm just saying it's this. So, this equals, let's multiply it out. I get alpha x cubed minus p alpha x squared plus alpha x. Now if I multiply beta in there, I get plus beta x squared minus beta px plus beta. This equals alpha x cubed plus x squared. My x squared terms are going to be beta minus p alpha. My x terms are alpha minus beta p, and I just have plus beta. So now, this has to be equal to this. This has to be equal to 0 x squared. So this thing has to be 0. Okay? This must be equal to this. And then the constant must be equal to the constant. Okay? So this is what the identities is. It says that if you've x cubed on the left and x cubed on the right, they must be equal. If you've x squared on the left, they must be equal to x squared on the right. So on the left hand side, I have no x squareds. But on the right hand side, I do. The only way for those two things to be equal is if on the right hand side, there are no x squareds, which means that this thing must be equal to 0, and therefore we get that beta must equal p alpha. Okay? From the green equation, we get that ax cubed equals alpha x cubed, which means that a equals alpha. And from the constant, we get that c must equal beta, and therefore beta equals c. So if I plug them in here now, I get that c equals pa, or c equals ap. That was the first thing I wanted to show. So that's this. Okay? So that's the first thing. Second thing that I want to show, I'm going to use this now. This and this. So I get that b has to be equal to alpha minus beta p. So I get that b equals alpha, we said was a, beta is c, and you've p. Okay? So I have this. I need to show that c squared, so I need to show c squared is going to be a into a minus b. So I need to get rid of the p, basically. So here, so c is equal to ap. So from that, okay, how do I show this? It's this thing I want to show. Yes, of course, yeah. I'm just going to solve this for p. So I get p equals b minus, no. P equals a minus b over c. Okay? And now I'm going to plug this in here. So I get c equals a into a minus b over c, and then multiply both sides by c, so I get c squared equals a into a minus b. And that's that one. Now the last one. The last one is simply going to come from here and this result. Sorry. No, sorry. Not that result. this result. So that I just put in there. So P equals A minus B over C, and C equals AP. So now I can multiply both sides by AP and get that AP squared is A minus B. Multiply both sides by minus 1. I get that B minus A equals minus AP squared. Okay, that was quite a difficult one. But the main thing to take away is that here, this is quite important. This step here, and then equating via identities that x cubed equal x cubed, x squared equal x squared, x equal x's, and constant equal constants. And that's how you solve that. Okay. Yeah, there's some more problems, but I can just leave those. So yeah, I think that's the end of Algebra 2. So it'll be Algebra 3 next. So yeah, thank you very, very much for putting up with me for that long. Yeah, thank you.